So 2 weeks and 3,000 lines of code later, I have finally managed to make my very first Godot plugin. My issue was that in games, setting up interaction sequences and cutscenes can be kind of challenging. You have to control the game state and puppet various objects within the scene. Now, most solutions I've seen to this problem are programmatic, such as having like an array of callbacks that are executed in a linear fashion. This plugin is my best attempt at simplifying the creation of event sequences by representing them as nodes in a graph. The lines represent the sequence in which events will execute. So instead of events executing linearly, they are able to branch, and their sequence is represented by these little connections. What we are looking at is the functionality of this chest object here. It's a very simple object, only has a few nodes within it. You can see where the chest starts. There are multiple entry points for this graph. In fact, there are 4 of them right here. The first one here is called when the chest is first created in the scene. This one is called when the player interacts with the chest. And then these 2 down here are what reward the player with a certain currency or item. Now, if we go and look at the chest script here, outside of some boilerplate code for the property inspector, there's very little code here, and in fact there's nothing that actually handles the functionality of the chest itself. So this right here is a test level in this project, and we have a chest object here, and this one is configured to give the player a weapon item with 135 bullets in it. So if we go ahead and test the scene and just walk up to it, we can open the chest and we get the gun, and it works. And we can interact with it again, and it won't open because it's already open. And if we leave and re-enter, you can see that it retains its state. Now, under the hood, all the events here are their own little scripts that adapt the command pattern. So they all just have a single method that is called by the main executor node, which is what stores the event graph resource, which is this graph down here. The event graph will execute a node, and then it will wait for the event itself to fire a signal dictating which port to travel on. So for single port nodes, of course they would only travel on the only port that they have, but like right here we have a conditional node that has 2 ports it can travel on. So this one is testing a flag in the player's save data, and when that flag is true it will go to the top port, and when it's false it will travel the bottom port. You can have as many of these ports as you want on an event. There's no real restriction to it. This approach lets us do some very complex branching that is still pretty easy to follow, just because it's visualized in this manner. Now, the actual front end for all of these events are generated using code. When I was designing this plugin, one of the big potential drawbacks that I had considered was the fact that you would have to pretty much hand design every single front end for every single event. So having to create a scene and a unique script to manage the UI for that event that it's representing, it sounded like it was going to add a lot of complexity and make creating new events really cumbersome. So if we look at the script for the sound event, and all this does is it just plays a sound effect. We have a method here called getEventProperties, and this is a builder pattern system where we have the event property class, and we have several subclasses for different data types. This here is pretty much what creates the interface. It is very simple to understand. It's very easy to configure these different fields, and it's very easy to add your own custom field types. And in general, it makes adding new fields and refactoring way quicker and way easier. There's also some support for more advanced properties, such as the string enums. This one, for the play animation event, is reactive to what the path here is set to. So if I go ahead and switch this to the animated sprite for the chest, we can see that it updates to its animation keys. And if I go back to the animation player, we can see that the keys are updated once again. So you may have noticed these orange fields in this event graph and this little syringe icon. You can mark any field in an event with a placeholder key, and that placeholder key can be anything. So at runtime, when you use the event graph executor node to execute the event graph, you can provide values to these placeholder keys. So if we look at the export properties for this chest here, you can see that we have a field for the state flag, the mutation type, and depending on the mutation, the item resource to give the player, or the amount of currency to give the player. And in the script itself, you can see that we are assigning those values to these keys, and we are binding those values to the event graph executor. This system is known in programming as dependency injection, and it will save the designer a lot of time, because otherwise, for every unique chest, you would have to create a unique version of this setup here and tweak the values to suit your needs. And well, that is a lot of manual work. Now, having this system is very beneficial because we can break down a lot of basic things into individual components. Like here I have this little cactus guy who saves your game, and his entire functionality is pretty much contained in this little graph here. And likewise for this plant here, that when you interact with it, it'll heal you. It's very simple. My general goal behind this plugin is to minimize the amount of repeat work you might have to do when creating these various things. And in the end, I think I achieved my goal pretty well, as most of our entities in this game have already moved over to the system. Thank you for watching. I plan on releasing this on my GitHub at some point soon. However, right now it's kind of a little intertwined with the current project it was made for, but I do plan on decoupling everything and releasing it standalone sometime in the future. If you like what you saw and want to maybe see more videos like this one, then feel free to subscribe.